So in terms of the traditional approach with regards to holding and storing and securing your own data, it's generally understood that the owner of the data, would build data centers ourselves. And those data centers, comprising servers, etc., will either be near to the organization or to nearer where our customers are. Now, that in itself means that there could be some latency issues, because if it's further away from the organization, it brings in delay to us, or further away from the customer, it brings delays to them. Now, by being responsible for our own data centers, we'd have to guess the maximum peaks. And if we guess them wrong, if we guess too low, then customers will suffer poor performance, again, latency and other issues. And if we guess too high, then we'd be paying for resources that are underutilized, and that would be a waste of money. In terms of the new cloud computing approach, there's a number of factors that we should consider. First of all, we will access data center resources and products via the internet. These include servers, databases, storage, plus higher level application components. We'd also be able to make use of Internet of Things, analytics, networking, developer tools, management tools, as well as enterprise applications. With cloud computing, we'd also have faster access to resources in terms of being able to deploy them very quickly. We'd also be able to make use of using the right partner of our cloud computing to have a global reach, which would be local to customers, thereby dealing with latency issues. In terms of scalability, we'd be able to scale up to meet peak demands. We'd be able to scale down to provide minimum resources needed. And that would be automated rather than based on worst case scenarios, automated by figuring out what are the parameters, what are the ranges where we need to scale up or scale down. From personal experience, having worked on projects at airports tend to have higher peaks around the holiday season, or when larger airplanes such as the A380 are expected to land and take off. And they would also know when to expect that there'd be fewer flights. So that would be a real life example of where peaks are generally known to be understood by calendar, but then there's the means where you have to scale up or scale down when the unexpected happens. And new cloud computing approaches should help with that. Resources should be disposable, so we take and we pay for what resources are needed. Wastage and underutilized resources are vastly reduced. So unlike the traditional approach where you are having to preempt what you need and pay for it up front and have it on site already, what you're doing with disposable resources is saying, when we need it, we'll automate the request for it. Therefore, we're only paying for what we're using. So wastage and underutilized resources are reduced. And therefore, costs reflect usage rather than worst case planning, which is what the traditional approach often requires. In terms of cloud computing and reliability, you want reliability to include recovering from infrastructure or system failure, and also for the system to remain operational even if some part of it has failed. In terms of well-planned foundations, what you want to be able to do there is to make sure you've thought through what changes in demand could happen and how they're going to be handled. You also want failures in the system or the infrastructure to be detected, and you want automatic self-healing to occur. Now, if you go down the traditional route, you would be looking at someone to handle those manually, and that becomes longer to implement. It can also cause conflict with your clients or your customers, and it can be very expensive. In terms of cloud computing and data security, you'd be looking at making sure the ownership and control remains with the client of the data, also including which region where that data is held, region in the world. Obviously, because you have to take into account the laws of where the data is stored. There are different laws in the United States of America compared to EU, European Union, and there'll be overlap, etc. You'd also want to have ownership as a client and control of your encryption keys, and we'll talk a bit more about security later on. Now, the traditional approach in terms of auditing the infrastructure security. That can be an arduous task, and it wasn't done very often. But with the cloud computing approach, monitoring is done continuously, and changes where they occur are responded to immediately with pre-planned responses, again based on parameters and ranges. Now, in terms of cloud computing, and we're now sort of talking about how AWS Cloud can help with being more agile, we want to look at some agility core factors, and these are increasing speed, ease of experimentation, and culture of innovation. In terms of increasing speed, that's not just increasing speed where data gets to your customer. It's also about how decisions can be made faster, and how making use of resources can be automated based on events as they occur rather than requiring human intervention to make that decision. But increasing speed, in terms of being agile, allows decisions to be taken sooner. It allows for resources to be deployed faster. It allows for people to preempt what's going to happen and have the systems automate responses as they occur. Now, in terms of ease of experimentation, you need the right technology where you have the space and the time to go off and try out new ideas, and that really relies on a culture of innovation, allowing people to look at their own experiences, look at the experiences of other corporations, maybe historically or currently, and being able to see how the systems would respond to that. So in terms of being agile, you really want things to happen quickly. You want ideas to be allowed to be tested and flourish, and you want your team to feel comfortable that they have the right resources in order to innovate, in order to improve what your organization is offering. And obviously that will help you in your marketplace establish yourselves as an organization who provides a greater level of service than your competitors. Now, it's understood that new security models require us to test often, patch quickly, and ensure that we give a fast response to incidents. And AWS Cloud allows for that to happen, particularly where incidents occur, that the system is self-healing and it doesn't collapse because a part of the system isn't working. In terms of risk reduction, now this is obviously something that you'd want to consider when looking at alternatives to the traditional approach. You want to be able to scale up or down to meet the needs, and you want to be able to do that automatically. So scaling up on resources, scaling down on resources, and of course correspondingly not paying for what you're not needing or not using. If a disaster event occurs, a flood, a fire, or whatever, you want to make sure coverage remains constant. Otherwise, your clients or your customers will be left hanging there with no access or restricted access to your systems. You want to be able to reduce the risk towards data security, and with that, you want to be able to make sure that your own organization's security policies, data policies are being able to be implemented, and you have the infrastructure support and backup that you'd get with a large partner such as Amazon. In terms of enabling agile behaviors, I've already touched on that briefly, but you really want to be able to respond to change with lower costs and a faster turnaround time. Obviously, in terms of risk reduction, you'd have access to Amazon's significant infrastructure as well as their expertise and experience and ability to provide the resources you need at any given time. And that sort of infrastructure can be really important for startups as well as long-established large organizations, which otherwise, under a traditional approach, you may have to either bring that in yourself as part of your own team or contract a third party to do it. Now, in terms of your security, the data centers that you'd be using with AWS Cloud, they're guarded 24/7. They have state-of-the-art electronic surveillance as well as multi-factor access control systems. And as I've already hinted at earlier or alluded to, your security policy can be baked into AWS resources, meaning that each time something is used, the policies that you have to ensure your own customers are satisfied with your approach to security, that they are maintained and considered throughout. So Who uses AWS Cloud? Well, a number of large corporations and startups use it for a range of products, web applications, mobile applications, game development, data processing, data warehousing, and archiving. So by looking at this mind map that I've done for you, what you should be able to do is to look at this and say, okay, we understand what the traditional approach, we understand what new cloud computing approach actually means, what AWS Cloud can do, and take that and then ask yourself if the traditional approach is where you are leaning towards, does it meet the things that cloud computing can do? And from that, you should be able to decide which direction you want to go to, cloud computing or the traditional approach.